In this question, they are saying that there's a small charged object and it is accelerating on a friction-free horizontal surface. There is an electric field that is present, and if the magnitude of the charge is 10 microcoulombs, the mass of the object is 5 grams, and the magnitude of the electric field is 4 newtons per coulombs. Find the magnitude of the object's acceleration. So we have some sort of an object, and this is accelerating, let's say to the right, and it's on a friction-free horizontal surface, so we are not considering the weight here, so we are just looking at the horizontal or the x-axis here, and we have an electric field. So we have the magnitude of the charge, so let's say we have a Q which is 10 microcoulomb. We have the mass of the object which is 5 grams, so 5 times 10 to the negative third kilograms. And then we have the magnitude of the electric field which is 4.0 newtons per coulomb. So what are the forces that are acting on this charged object? We have F equals QE. So this is a force, there's a charge and an electric field, and it's accelerating. So from Newton's second law, we also know F equals m times A. So these two forces are equal to each other. So that means we can write an equation saying Q times E is equal to m times A. So we are only looking at the magnitude here, and both forces are equal. So let's look at Q. So Q, we have 10 times 10 to the negative 6th coulomb. E is 4.0 newtons per coulomb, and that is equal to the mass times the acceleration. So the question is the magnitude of the object's acceleration. So if we isolate acceleration, we divide both sides by 5 times 10 to the negative third kilograms. So what we have is 10 times 10 to the negative 6, and we have 4 times 10, 4 times, see, 4nc, and then we divide that by 5 times 10 to the negative third kilograms. So what we have is an acceleration of 40 times 10 to the negative 6, and in the numerator we have 5 times 10 to the negative 3 in the denominator, and that gives us 40 divided by 5 is 8, and then we have 10 to the negative 6, and when we take the denominator 10 to the negative 3 to the numerator, we have 10 to the positive third, so that gives us 8 times 10 to the negative third meters per second, and that is the acceleration of this charged object.